Hello and welcome to Nikolai's Genetics Lessons, and today I have prepared very easy problem for you because this is 2 in the morning, so this was my choice today. The trait in the pedigree at the right is inherited from a single dominant gene. Question number 1, what is the probability that 2-1 is heterozygous? So let's take a look. This person would be heterozygous because this is rare genetic disorder and just one dominant allele is needed, and this person is also, we can assume that this person also heterozygous because one dominant allele is needed for phenotype to be affected. So we see here two heterozygous parents. So let's build a Punnett square. If one parent is heterozygous, another parent is also heterozygous. When we build a simple Punnett square, we can predict all the genotypes and phenotypes in the progeny. So here we would have capital A, capital A, small a here, capital A, small a here, and small a here. This genotype would show up as affected phenotype. This genotype also would show up as affected phenotype, and this of course also would show up as affected phenotype, and only this one would be normal phenotype. Looking at this pedigree, we can say that we can exclude this variant because here this person is affected. So we have to choose between these three, and as you see, 2 out of 3 probability that this person is heterozygous. But do not hurry, let's analyze pedigree of the progeny. So if this person would be homozygous dominant, 100% of his progeny also would be affected. So here's another Punnett square. So imagine that this person here is homozygous dominant, and this person here is homozygous recessive or normal phenotype and normal genotype. So once again, when we build a Punnett square, as you see, genotypes would be as follows: capital A, small a, capital A, small a, capital A, small a, and capital A, small a. So as you see, 100% of the progeny, regardless of the sex, because this is not sex-linked genetic disorder, 100% of the progeny would be affected. And we see here that 50% of the progeny, or at least one person, is not affected. That means that person here have to be 100%, we can be sure that he is heterozygous. So the answer would be 100% that this person is heterozygous, because we also excluded this variant. Now let's move to the next question. What is the probability of an affected child if the following cousins will marry? Cross 3-1 with 3-3, 3-1 and 3-3. And probability is 0, because if any of these people would have at least one dominant defective allele, the phenotype would be shown here as shadowed square or the circle. But we see that the phenotypes are normal. That gives us information that the genotype is small a, small a, small a, small a, and of course, if we cross this genotype with this genotype, all the progeny also would be small a, so they wouldn't inherit this genetic disorder. So probability that these two people would have affected progeny would be 0%. And this is going to be our answer to this question. And last question, cross 3, 2 and 3, 4. 3, 2 and 3, 4. Because we determined that this person is 100% heterozygous, and of course this person here is homozygous recessive, and we know that phenotype of this person affected, that give us genotype that is capital A and small a. This is going to be genotype of this person. So I hope you would be able to build a simple Punnett square and cross these two genotypes. So we know 100% that this person here has one defective allele and another from this parent is normal allele. So genotype of this person is heterozygous and genotype of this person is normal. So genotype of the normal, phenotypically normal person here, genotype of the affected person here on the side, and as you see, probability that these two people would have affected progeny would be capital A small a, capital A small a, small a here, and small a here. So probability would be 50% or 2 out of 4 or 1/2. So all these answers are the same. So we can put 50% here. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please write your comments, questions if you have any. And see you in the next video. Goodbye.